Good morning. I'm Lawrence G8NJJ, and together with Abby and Rick, we're here to tell you about a new radio called Saturn. Some of Saturn will be familiar to you if you know the HPSDR family. Other bits will be completely new. It's got Orion-like RF, but a totally new implementation. The major thing is we've added a new processor onto the board in the form of a Raspberry Pi 4 compute module, which has got a high-speed PCI Express connection, and that means that we can now run local programs on the board. Saturn's been created by a small team of us. We started something like 5 years ago. I did the concept design. I've designed the FPGA and written some of the early test software. Rick has been working on the software side, and Abby created the schematic, the PCB design, and organized the manufacture. So this is what's going to be on the Saturn board. The bits on the left and the bottom will be very familiar to anyone familiar with Orion. We've got two 16-bit A to D converters for 2 channels. We've got a 16-bit D to A converter and a transmit driver. We've got an audio codec, and we've got the Alex interface. The bit in the middle is different from the current products. We have a Xilinx FPGA rather than an Altera one, which has got a different design environment, although ultimately it's still coded, or at least some of it's still coded in Verilog. But the bit on the right-hand side is totally different. We've added a connection to a Raspberry Pi compute module, which means that we have on the board a reasonably capable processor with a video interface and able to act as the local computer for a range of purposes. Significantly, the gigabit Ethernet connection is routed through the Raspberry Pi. So here's the Saturn board. The left-hand side of that line is very much like Orion. The FPGA has got the blue heatsink on it, but we've got the receiver section here, we've got the transmitter section here, we've got the power supplies over here, and ultimately all of the things that you would expect to find on Orion. But the major difference is we've got a PCI Express connection to the compute module, and to the right hand side of that line, roughly speaking, we've got a Raspberry Pi 4. That's got all of the interfaces you expect with USB, Ethernet and video. It's got a Linux file system and an ability to connect an LCD display. The performance we've created is comparable to Orion in RF terms. We've got 10 down converters in our design, and it supports the full set of sample rates that Orion does. The RF performance is comparable to Orion. We've got a similar noise floor on the receive side. On transmit, the IMD is better with pure signal, but we're able to transfer data at quite a high speed from this board, and we can stream data from all of the DDCs at the maximum rate apparently. One of the major benefits of Saturn is that we've removed the Ethernet interface from the FPGA. That's now provided by the Raspberry Pi with Linux device drivers, and it's a standards compliant implementation. So the data is now routed through the processor to get to the destination if you're using a remote program. The Raspberry Pi is capable of running local programs for a variety of purposes. That can include admin functions, but it can also include running DSP applications, so that we can have a complete radio on that single board. So we've thought of 4 different ways that you might be able to use Saturn, and they're all on this diagram here, and I'll step through each of them in turn. The first of those is possibly the easiest to describe. We have the Saturn SDR connected to a PC that's running the Thetis program. It communicates using protocol 2 over Ethernet. Remember that Ethernet is now routed through the Raspberry Pi, but just as a transparent data transport process. We run an app called P2 app on the Raspberry Pi, and that emulates the protocol 2 front end and transfers data in the same format. The next application is to run a local DSP application running on the Raspberry Pi connected to an LCD display. And we can connect a front panel to that. We've got something resembling the Andromeda front panel ready to be connected, and we can run OpenHPSDR on that processor and have a complete single board radio. The third application is to run a local application on the Raspberry Pi, but just connected to a different monitor and a keyboard and a mouse, so you can run OpenHPSDR in its native mode, all in HPSDR. The fourth application we haven't coded yet, but it's very possible to do this. We could operate this as a thin client. So on the Saturn board, we could run a program that does the DSP for the radio function, but doesn't actually have a locally connected display and user interface. Those would be routed through the internet to a remote computer. Maybe that would be a web browser, maybe that would be another program. That's something we can't do at the moment with Orion. That would be very possible with Saturn. So where are we with Saturn? Well, we've got working prototype boards. We've got a working FPGA that's able to transfer data. It's got all of the functionality included into it now. And recently we've added the ability to reprogram if there's a error occurs during transferring the flash image. So it's kind of production ready on the FPGA side. We've got some working software. We've got the Protocol 2 client application to work with a remote program like Thetis. We've got a GUI program to write the flash to do FPGA updates. We've also got a command line version if we need it, and various debugging aids. So it's kind of a QSO ready radio. We've had this working with OpenHPSDR and with Thetis. We've still got some more work that we're getting on with at the moment. We're adding a native data interface into OpenHPSDR, and there will be some kind of an audio checker application for testing microphone audio. We've got a crude version of that at the moment, but it needs to be tidied up. For those that are interested, the Xilinx FPGA design uses a totally different process from that which has been used to date. The design starts off as a block diagram, and a lot of what's in the design is readable by non-FPGA designers. A range of people with skills other than FPGA design can look at that block diagram and understand the information flow. Some of the blocks in the design are Xilinx intellectual property. We can configure those so we know what's in there. We don't get to see the source code behind them, but a block, for example, that implements a bus switch, that there is a bus switch between the various on-chip buses. We don't need to know what the implementation of that is. It's just available to us. An FIR filter, we specify the functionality that we want the filter to have in terms of the number of taps, the coefficients, and the word widths. It writes the Verilog code. Other blocks, these ones that say RTL on them, they are Verilog blocks in just the same way as we have Verilog at the moment. Some of those are existing HPSDR IP. Other ones are blocks that I've written specifically for Saturn. I've tried to minimize those to maximize use of the Xilinx IP so that the design is readable by a wide range of people. For those that are interested, there's a tutorial about the Xilinx design process available that I gave at an SDRA conference. There's another presentation about the data interface to the Raspberry Pi, and you can look at the GitHub repository if you're interested in seeing more of the code. So thank you for listening. We'll be happy to answer any questions that you have about Saturn.